Hey guys, welcome to your channel, Maths are Us.
This video we use example to talk about how to prove sequences. In this example, we can see 1 square plus 2 square plus 3 square endless. It's the sum from I equal to 1 to n's plus sum together. And part B, we try to find the result if n equal to 100. Now let's start. First things, we need to try to prove if this equation satisfied. Firstly, we set if n equal to 1. When n equal to 1, left-hand side will be 1 square equal to 1. Now let's see right-hand side. So right-hand side, because n equal to 1, it's 1 plus 1 plus 1. 2 times 1 is 2, and plus 1 divided by 6. And let's solve that. 1 times 2 times 3 divided by 6 equal to 6 over 6 equal to 1. So in this case, left-hand side equal to right-hand side. So this equation is satisfied. Now we can continue the next step. We say P1 is 2. Now because P1 is 2, how about Pk? Now in this case, let's set n equal to k. Now let's substitute in. So 1 square plus 2 square plus 3 square plus blah 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 and plus, it should be n. In this same position, we substitute k as the position of n. K square equal to 6 k plus n, because it was n plus n, and the 2n plus 1 become 2k plus 1. Now our number is 1 square plus 2 square plus 3 square plus endless. How about next number after k? So next number after k will be k plus 1, isn't it? So k square, next number will be k plus 1 square, the square of k plus 1. If we add these things in left-hand side, in right-hand side, we need to add the same number, k plus 1 square. Now, let's see this part. Let's move this part to here. So now, let's see, in this part, we try to make the same denominator by times 6 over 6. It will equal to k plus 1 times 2k plus 1 plus 6 times k plus 1 square over 6. We can see we have common factor k plus 1. Let's combine, let's share this common factor. K plus 1 times k times 2k plus 1 plus 6 times k plus 1 over 6. Now let's reorganize this expression. It will become like this. Let's do further. So it's k plus 1 and 2k squared plus 7k plus 6 over 6. Now let's factorize this part. 2k plus k plus 6. We use these methods. 3, 2. It will equal to k plus 2 times 2k plus 3. If we're not quite sure about this part of factorize, you can give me comments. I can give you another video about how to factorize this. Now let's find the k plus 1 as their common factor. First one, k plus 1, it's already there. Now, k plus 2 can be k plus 1 plus 1. 2k plus 3 can be 2k plus 2 plus 1. It can be, we can find the 2 as their common factor and plus 1 like this. Now we factorize them. Don't forget, over 6. Because as we said, n is equal to k plus 1. Now if we substitute n back, it will be n times n plus 1 and times 2n plus 1 over 6. So this things is just equal to our question. As P1 is 2 and Pk plus 1 is 2 as well. That's why Pn is 2. For all of when n is positive integer. Proved. That's one of the methods to prove this series. Now let's have a look. We have another method to prove the same thing. That's another method. Let's see, that's n. We say n equal to k. What is next number in this series? So next number will be k plus 1. So k plus 1 equal to n plus 1. Let's see this. In the series, next number will be k plus 1. So when we have this first one, second one, third one, plus the last one will be k plus 1 squared. In this part, as same as the first methods. Now let's see the right hand side, because we use k plus 1 to replace n. That's the next number of n. So we need to use k plus 1 to replace the same place as k and n was. N will be k plus 1 and time 2n will be 2 times k plus 1 and plus 1. Now let's see this bit. This part is equal to this part, isn't it? This is the left hand side of the equation in this series. It's equal to the right hand side, which is this. Now let's simply use this right hand side to replace this part as left hand side. Now all of this part will equal to k times k plus 1 times 2 k plus 1 over 6. Now we continue. K plus 1 square equal to. Now we times 6 in both sides to cancel the denominator. It will be look like this, plus k square. Denominator has been cancelled. After expand, it will be this in left hand side. Now let's see right hand side. Now we try to expand right hand side. This times 2k plus 3 is equal to. Now let's simplify the both sides. It can be 2k cubed plus 9k squared plus 13k plus 6. Now let's see right hand side. It's equal to 2k cubed plus these 2 is 9k squared and plus 13k plus 6. Now we can see both sides, left hand side and right hand side, are equal. Proved. Case closed. In this video, we use 2 different methods to prove a same series. Now let's see how can we answer the question B. In question B, because n equal to 100, we simply substitute n into the equation. It will be 100 times 100 over 1, and 2 times 100 is 200 plus 1, 201 over 6. We put in the calculator, simply find the answer is 338 and 350. That's done. Thanks for watching. Ciao.